Hi everybody. For the next little while we're going to talk about circles and their circumference. Starts off with a pretty good question. What is pi? I just want to use that for the symbol for pi. And let you tell me, what do you think pi is? And I don't want to have you tell me 3.14 or 3 and 1/7. Those are okay approximations of pi, but let me show you something I've been thinking about. Here's a circle. And this circle has, as close as I can make it, this size diameter. Pretty much that's the diameter of that circle. And let me just do a little walk with you for you. Let me start at an arbitrary place. I'm going to take the diameter of this circle and bend it along the arc of the circle as best I could. Try to match that arc of that circle. That's pretty close to right there, best I could. And I think the first time goes to about this place right there. So my question to you is, if I take the diameter of a circle and I use it to make the arcs of a circle, how many times will it take that diameter to go all the way around that circle? Well, let's take a look. It took a diameter goes once to this place, and then again, if I would mimic the arc of that circle around to about this place right there as best I can make it. So it's more than 2. In fact, it's a little bit more than 3, isn't it? Yeah, it's a little bit more than 3. If I get this as closely as I could measure, I'd say it's a little bit more than 3. It takes me 3 diameters to get from 1, 2 to 3, and a little bit more. In fact, what it is this pi. What is pi? Pi is a ratio. It is the circumference of a circle divided by the diameter of the circle. And don't you forget it, that's what pi truly is. It's how many diameters fits in the circumference of a circle. If we know that diameter, and it's going to fit across there, how many? A little bit more than 3 times, about 3.1415926. But so if we go with this, what is pi? The ratio of the circumference of a circle over the diameter of that circle. That's equal to pi. And when we start thinking about that for a second, if the circumference over the diameter is equal to pi over 1, what happens when you cross multiply there? We're going to get pi times the diameter is equal to the circumference of a circle. And I hold that to be an important little ratio of a little idea there, a formula that we're going to use. And in fact, since the diameter of a circle is equal to 2 radii, the diameter is equal to 2 radii, we could say that the circumference of a circle, instead of being pi times the diameter, is 2 times pi times the radius. Either one of those work pretty good for the circumference of the circle. I kind of like 2 pi r, but I got to admit that pi times the diameter works just as well. Then let's work through a series of questions, see if we can't make sense of these ideas. If a circle has diameter 14 centimeters, we just make such a sketch so I can keep that thought in mind. A diameter of 14. Give the radius and the circumference. Well, the radius is always 1/2 of the diameter. Since the diameter was 14, that would be 7 centimeters. Give the circumference of the circle. And let's just use C of the circle. Circumference of the circle like that. And the first thing I think is just pi times the diameter. Pi times 14. We could call that 14 pi, couldn't we? And that's a perfect answer. That's exactly valid. But it asked me for a decimal approximation. And we could use 3.14. That would be okay. I think I'm going to go with, turning on my calculator, I'll use the pi button and just go, this circumference of 14 pi would be 14 times, and hit that button for pi. My calculator's going to call that about 43.982. I'll call it 43.98 just for the moment. Circumference of that circle, 43.98. If this was measured in centimeters, this would also be measured in centimeters. That would be 2, wouldn't it? Okay, now we got this different circle P, with a radius of 12. Let me just make a little sketch about that, clue myself. This one has a radius of 12. It's named circle P. A circle's named by its center, I know. Give the diameter and the circumference. That'll be easy enough, huh? The diameter is 2 of the radii. The diameter would have to be 24. If that was feet, then the diameter would be 24 feet. Give the diameter and the circumference. And you know, as I know, the circumference of a circle is given by pi times the diameter. So the circumference of this circle be pi times the diameter, which was known to be 24. Yep. So we'll call the circumference of this circle 24 pi. And just leave it like that. I know that'd be around 72, 75 feet, probably something like that, but I don't need a decimal approximation every time. Same kind of thought here. Circle X has a circumference of 8 pi. Give the diameter and the radius. Say, well, that's pretty easy. Circumference is given by 2 times the pi times the radius. Could have done it that way. I could have gone also circumference is equal to pi times the diameter. But if the circumference is equal to 8 pi, so 8 pi is equal to 2 times pi times the radius, I can divide both sides by 2 pi. And pretty quick and pretty easy. I see the 2's will fall and the pi's will fall there. I'm just left with the radius is equal to, and 8 pi divided by 2 pi is just going to be 4. So I said under that circumstance the radius would have had to have been 4. Using that other formula though, if the circumference is still 8 pi, which is equal to pi times the diameter, but I want to know what the diameter is, I'll just divide both sides by pi. And clearly the diameter is left on the right hand side, and 8 pi divided by pi would just be 8. So it makes sense to me that the radius would have been 4 and the diameter would have been 8. Just warming up, starting this idea about circles. A circular track is 1,256 feet in circumference. I might visualize that. There's my circular track. What is the diameter and the radius? If all the way around here is 1,256, what must be the distance across that circle? What would be the diameter? And I go back to the formula. The circumference is equal to pi times the diameter. The circumference, the distance around this circular track is 1,256. That must equal pi times whatever our diameter must be. I'll divide both sides by pi. And that ought to lead me with the diameter of that circle. So I'm just going to do 1256 divided by pi. Let you get a look at it with me. You can divide by 3.14. We'd be pretty close. I just divided by pi. And that'd be about, I would relate that to be, well, I want to call that 400. But 399.8 would be okay as well. That'd be just about 400. I'll say approximately 400. But I might also say that the diameter was 399.8. If somebody wanted to know the radius, I could have said, well, it's half of that 400. It would have been 200. That's approximately. But you might also say, hey, the radius is just about whatever a half of 399.8 was, and I'll divide that by 2 and report that to be about 199.9. Just rounding, making a difference there, wouldn't be much to worry about. A bicycle wheel. This is a pretty good question. Here's that bicycle wheel. Has a diameter of 26 inches. All the way across there's a distance of 26 inches. How far would the wheel travel in one revolution? How far would that wheel go if it went one revolution? And would it make sense to me that distance that it would have to have traveled would be the same as the circumference of that wheel? If the diameter was 26, the circumference would be 26 pi. That would be the distance around the wheel, and that's what it would travel in one revolution. So let me answer that this way, 26 pi. And that would be about, we might want to say how many inches would that travel. Just get a look at that, 26 times pi. That'd tell me about 81.7 inches it would travel. And how far would it travel in 10 revolutions? Well, it makes sense that if it does 26 pi in one revolution, then it's going to do 260 pi in 10. 10 times as much as that. 260 pi. And that would be approximately equal to 10 times this amount. That would be about 817 inches, huh? We could divide that by 12 to know how many feet it would be, and we'll do that in a second. Let me just get a look at this thing. If I would have gone with that 260 pi, it would have given me about 817 inches, wouldn't it? And if I would have divided that by 12, then it would have been about 68 feet. Approximately 68 feet would travel after 10 revolutions. 68.1 feet, I guess. A truck has wheels with 17-inch radius. Let me get a look at that wheel. With a radius of 17 inches. How far would the truck go if each wheel made 20 revolutions? What I'd want to do is, well, how far would it go if it made one revolution? In one revolution, the distance traveled by this wheel would be the same as the circumference. The circumference of a circle can be given by 2 times pi times the radius. So the circumference of this circle would be 2 times pi times 17. 34 pi. That would be the distance that would travel in one revolution. 34 pi inches. So in 20 revolutions, it must be about 680 pi, I figure, huh? Let's take a look at that. If it was 34 pi, oops, did that wrong. Let me get that pi in place. 34 pi, going about 106 inches every, 106.8 inches with every revolution. But if we made 20 revolutions, let me multiply that times 20. And I figure it traveled about 2,136 inches. And that would give me, if I divided that by 12, divide that by 12, I did, and I get about 178 feet, huh? About 178 feet. A truck with 17-inch wheels that made 20 revolutions would have traveled 178 feet. A wheel travels 1,884 inches when the wheel is rotated 20 times. How big are those wheels? Same kind of question, huh? We're just gonna work that backwards. Let's see. Now, if it goes this far, 1,884 inches after 20 revolutions, how far would it go in one revolution? I'm gonna take a note about that. Say one revolution would be 1884 divided by 20. And then that would be the same as the circumference of the circle. Let me get a look at that. 1884 divided by 20. And I get this decimal number, about 94.2. That must be the circumference of the circle. If it goes that far in one revolution, that must be the distance around that circle is 94.2. Bear that thought in mind. The distance, the circumference around there is 94.2, but the circumference, that 94.2, is equal to pi times the diameter. I want to know what the diameter is. I want to know how big the wheels are. So let me divide both sides by pi. That'll leave the diameter. If I know the diameter, I think I can figure out the radius. So if it goes 1,884 inches when it's gone 20 revolutions, we'll divide that by 20 and we get 94.2 inches with every revolution. Divide that by pi, 94.2 divided by pi. That's probably about going to call that 30 revolutions, huh? Or the diameter, 30. The diameter is 30, as close as I can get. And therefore the radius must have been 15 inches. And that's a pretty good little collection of questions, but I've got some more I'd like to look at with you. Because I was looking across the assignments, they got these same kind of things. And here we're going to find some arc lengths. Really the trick is finding the radius. Here we have a square inscribed in circle X. And it tells me that the sides of the square are each 8, that AB is 8. What we have to do is figure out what the radius of that circle is for sure. And there's a couple ways you can do that. You can look at this right triangle. I know that this central angle will be a right angle. I know that because these 4 chords are all congruent, Therefore, these four arcs will all be congruent, and that central angle is the same as the arc it cuts. That's going to be a right angle right there. You'll just have to trust me. So, if that hypotenuse is 8, and this is an isosceles right triangle, how big is that radius going to be? That is a 45, 45, 90, isn't it? Take that hypotenuse, divide it by the square root of 2. Yeah, I think it's going to be 4 root 2, isn't it? That's what the radius of that circle would have been. I got another thought you might consider. If I showed the diameter of that circle, I know there's a right angle here. This length is 8, and this length is 8. What about that hypotenuse, which would be the diameter? It would be 8 times the square root of 2, also a 45, 45, 90. So we got a radius, don't we? And it was 4 root 2. I would be thinking to myself, what's the circumference of that circle also? And I know it's 2 times pi times the radius. So that would be 2 times pi times 4 root 2. So the distance around this circle must have been that product, 8 root 2 pi. And that's an ugly looking answer, but it ain't that ugly. It's something we could get used to. Ask me, how big is arc AB? And I'm certain that these 4 chords are congruent, and we should prove, and we'll do it soon, that congruent chords give us congruent arcs. We have 4 congruent arcs. They all add up to 8 root 2 pi, the distance all the way around this circle. So arc AB is 1/4 of that. 8 root 2 pi divided by 4. What do you think we ought to call that? Yeah, 2 root 2 pi, huh? That would be the length of arc AB. You could get a decimal for it, but I'd rather live without it. What if we talked about arc ADC? Now, when it's named with 3 letters, we've got to be a little more careful how we note that arc. From A through D, terminating at C. And that just has 2 of these size arcs, doesn't it? AD and DC are each equivalent to AB, so that's going to be twice as much as this. I think that's about half the distance around the circle. The full distance around the circle is 8 root 2 pi, but this one will be twice as much as that, which would be 4 root 2 pi. I think that's what would be the length of arc ADC. What about this ACD? You start at A, go through C, and terminate at D. Start at A, go through C, and then terminate at D. And that's 3/4 of the way around this circle. That must be 3 of those 2 root 2 pi's, therefore giving me 6 root 2 pi. 3/4 of the distance are all the way around that circle. 3/4 of that 8 root 2 pi would just be 6 root 2 pi. So I figured out a couple things about that one. Let's play with an equilateral triangle. Now, and the thing you had to figure out here was you're working with a 45, 45, 90. And in this equilateral triangle, we're playing with a 30, 60, 90 triangle. It tells me that PQ is 12. Could draw lots of little triangles in here, but I'm going to draw one like this. I know that the angles in this big triangle would have been 60 in each of the corners, and therefore this was going to be 30. I've gone to this chord perpendicular. I have bisected that chord. This must be a 60, and there's a 90. If PQ is 12, then I think this length has to be 6. This would have also been 6, but I don't care. Now I'm looking at this side right there, and that's the short leg, isn't it, opposite the 30. This is the longer leg opposite the 60. I want to go from the long leg to the short leg, 6. I got to divide it by the square root of 3. And 6 divided by the square root of 3 is going to be 2 square roots of 3, I hope you recognize. Rationalize that denominator, you're going to agree with me, I bet you. So I got the short side being 2 root 3. But I really do need the hypotenuse, which is the radius. The radius, the hypotenuse of about 30, 60, 90 triangle is always twice the short side, therefore it's going to be 4 root 3. There we got the radius of the circle. I would be thinking right away, what's going to be the circumference of this circle? The circumference of any circle is going to be given by 2 times pi times the radius. So that'd be 2 times pi times 4 root 3. And the distance around this circle, 8 root 3 pi. We could get a decimal on that, but I'm happy to leave it just like this for right now. So what about arc PQ? Well, what part of the distance around that circle is it? I've got three congruent chords, and congruent chords give me congruent arcs. So these are three congruent arcs. This must be one of three equal parts. Therefore, I would tell you that arc PQ is 8 root 3 pi divided by 3. Can you reduce that fraction? No, I can't. 8 divided by 3. No, I can't do that. I'm going to leave it in that form. 8 root 3 pi over 3. Then it asks me about arc PRQ. And you got to recognize that starts at P, goes through R, and terminates at Q. And that just has two of these, doesn't it? Arc PQ is this one, and so I'm thinking that that must be twice as much, and twice as much as this amount would be 16 square roots of 3 pi over 3. That makes sense to me. I hope that makes sense to you. Let's play a little bit longer. How about a regular hexagon? And in this situation, I'll tell you the perimeter of my regular hexagon is 48. You think, well, if it's a regular hexagon, then all 6 of these sides got to be the same, don't they? And 6 times something must give me that 48, so these must be 8 on a side, huh? Now, what we want to do is figure out the radius of this thing, and what you got to remember about a hexagon, if I were to show all of these radii, these 6 triangles are all congruent to one another. This would be 60 degrees of angle right there. I know that these radii are congruent. These are also going to be 60-degree angles. That's an equilateral triangle right there. And if this side is of length 8, then yeah, that radius is also of length 8. So what's the circumference of that circle? 2 times pi times the radius. So the circumference of this circle would be, if the radius is equal to 8, 16 pi. That's the distance all the way around this circle. So what about AB? Just arc AB. Some part of that 16 pi, isn't it? And I'm sure that each of these congruent chords give me 6 congruent arcs. Each one gives me a congruent arc. So it must be one of 6 equal arcs. So I would tell you that arc AB is 16 pi over 6. And I can reduce that fraction, can I? Because 2 goes into both of them. That'd be 8 pi over thirds. That's how long arc AB would have been that distance. And I'll tell you, that thing right there should be a little bit more than 8. In fact, you can tell that it would be 8 pi divided by 3. That's a little bit more than 8, huh? Because pi over 3 is a little bit more than 1. And then what about arc ECB? Let's start at E, go through C, and terminate at B. Arc ECB, that's half the distance around that circle. That's a semicircle, isn't it? But what I'm thinking for sure is it has 3 of those arcs. So it must be 3 times as big as this. And if I multiplied 3 times 8 pi thirds, the 3 in the numerator, the 3 in the denominator are going to cancel, and I'm just left with 8 pi. That is the distance over the arc of a semicircle. Wasn't it true that the full circumference was 16 pi? So ECB is halfway around the circle. It would be half of that 16 pi. It would be 8 pi. One more time. How about arc FCA? Starts at F, goes through C, and stops at A. From F through C to terminate at A. That is 5/6 of the way around this circle. That must be 5/6 of the full distance around this circle, which was 16 pi. Let's work on that for a second. 5 times 16, that's 80. 80 pi over 6. Seems like we can reduce that, huh? 2 goes into both of them, so that'd be 40 pi thirds. And you can leave it like that. I'm happy with that, 40 pi thirds. Somebody might say, hey, that's 13 1/3 pi, but I don't care for that. I like the 40 pi thirds just fine. That's how long that arc should have been. I think this is a good little workout. You do have a couple of other pages.